Hey guys, how are you all? So in this video we are going to discuss about the chemical reaction of alcohol and phenol. So before that I want to give the brief explanation about the boiling point. If you are completing the boiling point, your acid is always high boiling point. Then your alcohol, then your aldehyde and ketone, then your ether, then your alloalkane and allorenes, then your hydrocarbon. So this is the brief about the boiling point order. Just remember why this is, because these two form the hydrogen bond. Acid and alcohol form the hydrogen bond. Here there is a dipole interaction, here also dipole interaction, here dipole interaction, but in case of hydrocarbon only the van der Waals force of attraction. Clear? Right. We will start the chemical reaction of alcohol. So the alcohol can react in two ways. One in electrophilic fashion, another one is nucleophilic fashion. See, look here. There is a CH3, C, hydrogen and OH. This is ethanol, right? So here there is a two kind of cleavage is possible. One cleavage is here, one cleavage is here. If it cleavage A and B, if it cleavage A, alcohol react as a nucleophile. In case of cleavage B, it act as a electrophile. Clear? So the first one, so here there is a cleavage of here, so it act as a nucleophile. The bond between CO is broken, they react as a electrophile. Clear? So here there is a protonation. After that there is a breakage here. So this is here alcohol act as a electrophile. The alcohol react with your metal sodium, then sodium hydroxide. So I will explain the base and acid. So look here, this, if you are taking the standard electrode potential or reduction potential, your sodium is more standard electrode potential compared to your hydrogen. So sodium can easily displace the hydrogen here, so we will get the sodium alkoxide. Again the aluminum is standard electrode potential is more compared to hydrogen. So easily displace the hydrogen here. So whenever the acid and alcohol react with metal and base, at the time there is a formation of H2 gas. Right? So here this is act as acid, this is base, there is a formation of salt, sodium phenoxide, this is water. Now I will take the water, and I will take the alcohol. Which one is more basic? I am going to compare the basic character. Which one is more basic? In this, if you are comparing the hydrogen and alkyl group, this is more electron releasing. Electron releasing group increase your basicity. So the reaction is, if I take the any one base, it react with your alcohol. So base react with your alcohol act as acid. At the time it will give proton, right? So there is a formation of BH and your conjugate base. So acid, after giving the proton, it become a conjugate base. The base, after accepting H plus or proton, it become a conjugate acid. Clear? Right. Now we compare the acidity of primary alcohol, secondary alcohol, tertiary alcohol. Right? So look here, if I am taking the RCH2OH, this is primary alcohol. If I am taking the 2 alkyl group in OH bonded carbon, this is primary, this is secondary. In case of tertiary, this is your tertiary. So here there is a 1 electron releasing group to the OH bonded carbon. Here 2 alkyl group to your OH bonded carbon. Here there is a 3 alkyl group to the your OH bonded carbon. Okay, so if it electron releasing group get increases, electron releasing group increases, at the time your basicity get increases. Your basicity get increases, your acidity get decreases. Okay, so this is most basic in nature. This one is most acidic in nature. Have you understand? Okay, so electron releasing group increase the basicity, decrease the acidity. You have to understand this one. Clear? If you are comparing the alcohol, okay, and water, okay, you are comparing the alcohol and water. So if I am taking the ROH plus H2O, this time here there is electron releasing group is there, here there is no electron releasing group. So your alcohol going to be more basic compared to your water. Okay, so then this one act as a base. Okay, this one act as a base. Okay, so what is the reaction it is going to be? There is a reaction it is going to be is, so if it extract the proton, what it become? It become a O plus plus OH minus. Okay, so they given just RO minus base. So from the alcohol, so it react with ROH water, it going to form the alcohol plus OH minus. Okay, so since the water is acid, that form the conjugate base. Okay, so this RO minus is base, it form the conjugate acid. Clear? This is the conjugate acid. So next one, acidity of phenol. Next one, acidity of phenol. Okay, so the reaction of phenol with metal, sodium, aluminium, sodium hydroxide indicate that acidic nature. Okay, because at the time there is a replacement of hydrogen from your alcohol, right? So hydrogen get removed. Then there is a hydroxyl group in phenol is directly attached with the sp2 hybridized carbon. Yes. Okay, so all carbon are sp2 hybridized. So if it OH is bonded, it is connected with sp2 hybridized carbon, right? Next, so ring act as an electron withdrawing group. Okay, so this benzene ring is electron withdrawing group. Electron withdrawing group increase the your acidity, decrease your basicity. Okay, so next one, the due to this the charge distribution of phenol molecule depicted in the resonance. Okay, the charge distribution. Okay, so your oxygen going to get the positive charge, the carbon which has the negative charge, this negative charge going to delocalize on ortho and para position. Okay, the reaction of phenol with aqueous sodium hydroxide indicate that the phenols are stronger acid than alcohol and water. Let us examine how compound in which the hydroxyl group attached to aromatic ring more acidic than one in which attached with alkyl group. Okay, now if it OH is attached with your sp2 hybridized carbon, then in normal alcohol it is attached with sp3 hybridized one. Here this is sp2 hybridized one. Okay, so due to high electronegativity of sp2 hybridized carbon, this is sp2, right? Okay, due to high electronegativity of sp2 hybridized carbon of phenol to which the OH is attached, the electron density increase on the oxygen. Electron density not increases, decreases. Sorry. Okay, the electron density get decreases. How? Here there is a 2 lone pair of electron, right? So this is electron withdrawing group, right? This electron withdrawing group pull the electron towards the benzene ring. At the time the electron density get decreases. Okay, so this increase the polarity of OH bond. Result in increase in ionization of phenol then that of alcohol. Okay, now let us examine stability of alkoxide and phenoxide. So alkoxide ion negative charge is localized on oxygen, while phenoxide ion the charge is delocalized of the negative. So look here, this is your electron withdrawing group. Okay, this is your electron withdrawing group. So this electron withdrawing group, what it do is it going to decrease the electron density over the oxygen. Okay, so at the time the oxygen and the hydrogen bond is more polarized, okay. So at the time it get ionized, right? So if it get ionized, the same ionization possible also in the methanol. So this is not electron withdrawing group, instead this is electron releasing group, increase the basicity, decrease the acidity, okay, right? So at the time, if there is a formation of your methoxide ion, your phenoxide ion, okay, in your methoxide ion, this negative charge localized over the oxygen, but in case of phenoxide ion, the negative charge, okay, negative charge delocalized in the benzene ring, okay. At the time, the stability of phenoxide ion is more compared to your methoxide ion. Stability of phenoxide ion is more compared to your methoxide ion, okay. So at the time, your acidic proton, your proton easily get detached from your phenol compared to your methanol, okay. What is the reason? The one reason is the OH directly bonded with sp2 iodized carbon, so that is more electronegative in nature because S character is more. Then your benzene is electron withdrawing group, decrease the electron density. At the time, your oxygen and hydrogen bond is more polarized. At the time, it easily broken, the H plus is given, okay. So that is the reason why your phenol is more acidic compared to the your methanol, okay. So we will compare the some of the example which is given here, okay. So if I am taking the phenol, in that I am substituting the electron releasing group, electron withdrawing group, okay. So this is your phenol, in that I am substituting the electron withdrawing group, and as well as I am substituting your electron releasing group, okay. So electron releasing group going to, okay, decrease your acidity and increase your basicity, okay. Electron withdrawing group, okay, going to increase your acidity, decrease your basicity. This is very important. Electron releasing group decrease your acidity, increase your basicity. Electron withdrawing group increase your acidity, decrease the basicity. Clear, right? So look here, your methyl substituted, all phenols are, okay, all phenols are, the pKa value is less, pKa value is more, then basicity is more, okay. At the time, the acidity is lesser, okay. The pKa value is lesser means more acidic, okay. The acidic is more. pKa value lesser means acidic will be more, okay. pKa value higher means the acidity will be less, okay. This thing I want to explain to you. Now we will solve the one question, okay. We will solve the one question. Look here, ma. Arrange the following compound increasing order of their acidic strength, okay. First we will write all the molecule structure, okay. Then we will compare, okay. First molecule, what is they given? Propanol they given, okay. Propane 1-ol which is given. There is a 3 carbon, right? 3 carbon in present in the propanol. In the first position, there is a OH group is present, okay. The first position, the OH is present, okay. So the first molecule is propane 1-ol. Then your second molecule is phenol, okay. So the third molecule is 4-methyl phenol. Fourth molecule is 4-methyl phenol. Then we have 3-nitrophenol. OH in the third position, the nitro group is there. Then 3,5 dinitrophenol. So here there is a third position, there is a fifth position, okay. Then there is a 2,4 dinitrophenol, 2,4,6 trinitrophenol. Look here, 2,3,6 NO2, okay. So 2,4,6 trinitrophenol. Clear? So look here, there is a phenol and your alcohol, okay, aliphatic and aromatic. The aromatic will be more acidic, we know that, right? So this is phenol, okay. In this case, your phenol which is attached with electron releasing group in the one molecule, so this is going to be less acidic compared to your phenol. The rest of the 3 molecules more acidic. So here in case I written OH, okay, this is not OH, this is NO2. This is your NO2. Sorry about it. This is NO2, here also NO2. Clear? So in this case, your trinitrophenol, this is 1, this is 2, then this is 3, then this is 4, this is 5, this is 6. Okay, so 1 is more acidic, then 2, then 3, then 4, then 5, then 6. Clear? Okay, so as I told you, electron releasing group decrease the acidity, electron withdrawing group increase the acidity. Clear? We discuss about the esterification reaction. Okay, this esterification, when alcohol react with your acid, then your acetic anhydride, okay, then it is react with acetyl chloride, it form the ester, okay. So look here, your ROH, okay, react with your acid, this is your acid, then your acetic anhydride, then it is react with your acetyl chloride. At the time, so this I can write slightly in different way. Your acetyl chloride, Cl, C double bond O, R. Okay, so this hydrogen and OH become a water. It give rise to R, C double bond O, OR plus H2O. Okay, this water should be removed. This reaction is reversible. This reaction going to be conducted in acidic condition. So that is the reason why we are using H2SO4. We are using the H2SO4. Okay, so here there is a formation of water, right? This water amount is get increases at the time the equilibrium shift towards the your left hand side. So as soon as the water is formed, if you remove the reaction, always remain in the right hand side. Okay, so there is a more product formation if you are removing the water molecule. When it comes to second one, so your hydrogen, okay, your acetate molecule become an acid. Your hydrogen and acetate molecule become an acid and give rise to your ester. Okay, give rise to ester. This is also in your acidic condition. The third one I will explain in a different way. Third one, again we are taking the alcohol react with your acetyl chloride. This hydrogen and Cl, okay, get removed as HCl, and there is a formation of your ester. Okay, this is third reaction, but in this we are using the pyridine. This is more basic in nature, acidic nature, it get neutralized. Okay, so this will lead to formation of more ester product. Okay, then the third one, there is a formation of aspirin, right? Okay, there is a formation of aspirin from salicylic acid. Okay, so this is your salicylic acid, okay. Here in this there is a reaction take place is acidic anhydride. Okay, again this hydrogen combined with acetate molecule, there is a formation of acetic acid. Then the rest of the acetyl group going to join with oxygen, right? So this become a O, C double bond O, CH3. Okay, this we call it as a acetyl salicylic acid. This we call it as aspirin. This aspirin is used in the analysis and antipyretics and anti-inflammatory. Okay, so all these three uses is by your aspirin. Clear? Then there is a alcohol react with your hydrogen halide. Okay, for hydrogen halide I take the example of HCl. Okay, so this is your your primary alcohol, then your secondary alcohol, then your tertiary alcohol, then your tertiary alcohol. Tertiary alcohol not going to have any hydrogen in that carbon. Okay. So now I am going to use the Lucas reagent, that is HCl, right? HCl. In this, the zinc chloride is not needed, but in case of tertiary alcohol, it is more reactive. So you will get turbidity as soon as you add the HCl. But in case of secondary alcohol, it need the Lucas reagent, ZnCl2. But even though ZnCl2 is added, the reaction, no reaction when it is a room temperature. Okay, if I am eating, then only we are able to get it. But after 5 to 10 minutes, we will get the turbidity in case of secondary alcohol. Okay, so if it immediately get, your alcohol is tertiary alcohol. If it after 5 to 10 minutes, then it is secondary alcohol. No reaction at room temperature, that is your primary alcohol. This is how we have to do it in the practical exam. Okay. Then we have reaction with phosphorus trichloride. Oh, the reaction with phosphorus trichloride, phosphorus pentachloride, I will discuss it, okay, great detail in the all-alkane and aloins. Go and watch that video. Okay. Then there is a dehydration reaction is there, right? So dehydration nothing but there is a removal of your water molecule. There is a removal of your water molecule. Okay. So if I am using the dehydrating agent H2SO4 at 443 Kelvin, so this water molecule get removed. There is a formation of your ethene. There is a formation of ethene, CH2. Okay. Then we will go for next. Okay, so here there is a secondary alcohol, here there is a tertiary alcohol. So as I told you, the reactivity towards the dehydration also, the tertiary is more reactive compared to your primary and secondary. Look here, CH3, CH, OH. Here I am taking the hydrogen here. Okay, for secondary alcohol, what is the reagent we need to use? 85% of your phosphoric acid, H3PO4, then 440 Kelvin, we will get the your propene. Okay, what is your byproduct? Water. In case of tertiary alcohol, for tertiary alcohol, we need not to use that much acid. We need to use only 20% of acid. 20% H3PO4 and 358 Kelvin. We are going to get the product is isobutylene or 2-methyl 1-propane. Okay, so shall we discuss the mechanism of your dehydration bit detailed? Okay, look here, your first one is protonated alcohol. Okay, so your oxygen going to abstract this proton, right? So protonated alcohol we will got it, right? Then there is a formation of carbocation. When there is a removal of water molecule, at the time there is a formation of carbocation. Then once the carbocation is formed, after, in order to, this is hyperconjugation concept, right? So this alpha hydrogen just move here, this hydrogen get removed. After that there is a formation of ethene. Clear, right? Next we go for the oxidation reaction. Okay, so in this oxidation reaction, otherwise we can say the dehydrogenation. What is dehydrogenation? Dehydrogenation nothing but removal of hydrogen. If I am taking the primary alcohol, if it undergo the dehydrogenation or oxidation, at the time we will get the aldehyde. Primary alcohol give rise to aldehyde. Secondary alcohol give rise to ketone if it undergo the dehydrogenation or oxidation. Okay, the tertiary alcohol, okay, the OH bonded carbon not having any hydrogen in it, so most probably no reaction. Okay, so tertiary alcohol will not undergo the oxidation reaction. Okay, so look here, the cleavage of formation of bond occur in oxidation reaction. These are also known as dehydrogenation reaction. The reaction has this involved the loss of hydrogen from the alcohol molecule depending upon the oxidation agent. The primary alcohol is oxidized to aldehyde, which in turn oxidized to carboxylic acid. If you are further oxidizing the your carboxylic acid, so Here there is a removal of hydrogen, okay, there is a formation of aldehyde, then further oxidation, there is a formation of carboxylic acid. Then, so in case of strong oxidizing agents such as acidified potassium permanganate, used to getting the carboxylic acid from the alcohol directly, okay. So C2C, CrO3, that is chromic oxide, anhydrous medium, oxidizing agent, so for this isolation of aldehyde, okay. So this is your alcohol. If I am using the strong oxidizing agent acidified potassium permanganate, okay, so at the time I am able to get the alcohol directly, okay, I am able to get the acid directly, okay. So if I am using the mild oxidizing agent, this alcohol become a aldehyde, this aldehyde become a acid, this aldehyde become a acid, okay. So here there is a selective oxidation is there, okay. PCC, what is PCC? Pyridinium chlorochromate, okay, pyridinium chlorochromate, okay. So this selectively oxidize the primary alcohol, give rise to aldehyde. In case of secondary alcohol, it give rise to ketone. So tertiary alcohol do not undergo the oxidation under the strong reaction conditions such as strong oxidizing agent and elevated temperature. Cleavage of CC bond take place and the mixture of carboxylic acid containing lesser number of carbon atom is formed. In case of tertiary alcohol, the tertiary alcohol so this is tertiary alcohol. If I am using the mild oxidizing agent like CrO3, I am using the KMNO4, okay. So at the time here there is a no reaction. If I am using the tertiary alcohol, okay, so mild oxidizing agent, no reaction. But in case of KMNO4, there is a carbon cleavage going to happen, okay, cleavage going to happen, there is a formation of acid. The same reaction, when vapors of the primary secondary alcohol passed through the heated copper at 573 Kelvin, dehydrogenation take place, okay. So dehydrogenation take place in case of primary alcohol, secondary alcohol, but in case of tertiary alcohol, there is a removal of water molecule, okay. So this product is isobutylene. So dehydration is possible, okay. Tertiary alcohol undergo the dehydration, tertiary alcohol undergo the dehydration, but in case of secondary and primary alcohol, which is undergo the dehydrogenation. Clear, right? Okay. So this is bit the complex, okay. So if the alcohol consumer, if they taking the ethanol, okay, so no harmful to the your health. But in case this ethanol mixed with your methanol, this is not good for health, okay, because this is going to produce your formaldehyde. This formaldehyde, okay, produce the blindness or even death, okay. So whenever there is so many persons in the villages, they are trying to produce the alcohol their own way. By mistakenly, if there is a formation of methanol, this lead to formation of your formaldehyde. This, if they are consuming the your methanol, it become a formaldehyde. At the time, there is a more possibility of blindness and even death, okay. Next we are going to discuss about the electrophilic substitution reaction in the your phenol, okay, your phenol. So in phenol, the reaction take place on aromatic ring, okay. So electrophilic substitution reaction, the OH group attached to benzene ring activated towards the electrophilic substitution reaction. So this is your phenol, okay. The phenol going to increase the activating group, right? This is activating group. It means that electron releasing group. The OH is electron releasing group. So at the time it increase the electron density on the ortho and para position. So electrophilic substitution occur on ortho and para position, okay. So it direct the incoming group into ortho and para position of the ring position, becoming electron rich due to resonance effect of OH group. The resonance structure as are shown under acidity of phenol, okay. So the first one is the nitration. If there is a using of dilute HNO3, okay, at 298 Kelvin, there is a mixture product, that is ortho and para nitrophenol, okay. So in this, your ortho nitrophenol is more volatile, okay. Your ortho nitrophenol is more volatile. It is more volatile compared to your paranitrile. phenol. Okay, this mixture can be separated by steam distillation. Why it is your orthoisomer is more volatile? Because in case of orthonitrophenol, there is a formation of hydrogen within the molecule. Okay, but in case of your paranitrophenol, formation between the molecule. So the association of molecule possible in your para isomer, but association of molecule not possible in orthoisomer. So that is the reason why it evaporates easily. So this is more volatile compared to your para isomer. Clear? Right. Next we go for the another reaction, that is with concentrated nitric acid, the phenol is converted to 2,4,6 trinitrophenol. The product is commonly known as picric acid. This is more acidic, as I discussed already. Okay, but the yield of the reaction product is poor. Okay, nowadays the picric acid is prepared, okay, treating first with concentrated sulfuric acid converted into 2,4 disulfuric acid. Okay, so first we do the sulfonation. At the time. So we can use the oleum, right? So we know the oleum formula H2S2O7. Okay, so 2,4 SO3H, second position, and fourth position SO3H. Okay, disulfonic acid. Then it is react with concentrated HNO3. Okay, then there is a formation of this picric acid. Clear? Right? Fine. There is a reaction which is taking place. Okay, so both phenol. Okay, but here they are using the CS2 as a solvent. Here water is a solvent. Okay, water is a solvent. So phenol, okay, react with Br2. Okay, so here they are using the non-polar solvent. Here we are using the polar solvent. If it non-polar solvent, your product going to be 2-bromophenol and 4-bromophenol. But in case of your solvent is polarized one, at the time we will get the 2,4,6 tribromophenol. This is white precipitate. So if you want to do in a practical whether given molecule is phenol or not, okay, so what we are going to do is we are going to use the bromine water. We will get the white precipitate of your 2,4,6 tribromophenol. Clear? Next reaction, we will solve the 7.5 exercise. Okay, example sum, right? So what is your question? Write the structure of the major product of expected, okay, from the following. Okay, so what they given? There is a mononitration of 3-methyl phenol. First I will take the 3-methyl phenol. Okay, 3-methyl phenol. So this is very, very important if you are studying for the NEET and IIT exam. Okay, so look here. So we are doing the nitration. Okay, okay, at the time we are able to get the two product. So with respect to this group, this 2 ortho, this is para. With respect to this OH, this is ortho, this is para. Okay, so the product is going to be 4-nitro, okay, 3-methyl 4-nitrophenol, or we can do the 3-methyl 6-nitrophenol. Okay, so how this ortho, okay, this is ortho, this is ortho para. Okay, so for this is ortho position, this is your with respect to this is the meta position, right? This is para position. Okay, so the reaction might not be possible in the meta position, but it is only possible in the ortho para position. At the time the product going to be, so this is OH group, right? With respect to this, the NO2 going to be here. Okay, so the first product. Okay, the second product, so your OH is here, your CH3 is here, here is the NO2. Okay, the NO2 group attachment is directed by OH. Okay, if you are comparing the OH and the CH3, your OH is more activating. Clear? right. So we will go for the next reaction, dinitration. Okay, dinitration of, okay, your 3-methyl phenol, dinitration of 3-methyl phenol. Okay, so 3-methyl phenol. Okay, we have to do the dinitration, right? 3-methyl phenol. When we do the dinitration, with respect to this is ortho, this is para, this place the attachment of NO2 is not possible because the steric hindrance of OH and CH3. So with respect to OH, this is ortho, this is your para, this is your product. Clear now? Next we go for the mononitration of phenyl methanoate. So phenyl methanoate, what is the structure of phenyl methanoate? So this is phenyl, so methanoate means this is your methanoate, this is your methanoate, this is the bulkier group. So ortho position attachment is not possible because of steric hindrance. So your para product only the possibility. Okay, OC double bond O CH3. So here is the NO2. Clear? Right. Then we go for the Kolb reaction. Okay, the phenoxide ion is generated by treating phenol with sodium hydroxide is even more reactive than phenol towards the electrophilic aromatic substitution reaction. So hence undergo the electrophilic substitution with the carbon dioxide, the weak electrophile. So ortho hydroxy benzoic acid is formed. Okay, so look here, what they saying is, if you are taking the phenol and phenoxide, okay, so this is more reactive towards the electrophilic substitution reaction. That is the reason why first they are generating the your phenoxide, then your phenoxide. So your this is your sodium phenoxide, right? Sodium phenoxide. Okay, sodium phenoxide. So in this this ortho and para position is more electron density, so it is going to attack the electron deficient position of the carbon. Okay, why it is electron deficient? We know that, right? Oxygen is more electronegative compared to the carbon, so the electron moving towards the oxygen, here the electron deficient going to be. So that is the reason why the electron is rich. Okay, here the ortho position is going to attack the carbon. Then there is a formation of your salicylic acid. Okay, then when it comes to Riemer-Diemen reaction, first, on treating phenol on chloroform in presence of sodium hydroxide, okay, the CHO group is introduced in ortho position of the benzene ring. Then this reaction is known as Riemer-Diemen reaction. Okay, the intermediate substituted benzene chloride, okay, is hydrolyzed in presence of alkali to produce the salicylaldehyd. Okay, so look here, first there is a formation of your alkoxide, OH group. When it react with NaOH, what it going to form? It is going to form the phenoxide. Okay, it is going to form the your sodium phenoxide. This sodium phenoxide when react with chloroform, chlorine CHCl2, here there is a one hydrogen is there, right? This hydrogen, this Cl get removed. What is the product we are going to get it? Is, look here, ONA CHCl Cl. Okay, this again react with alkali OH minus. What it going to form is, I am taking the NaOH, Na plus OH minus. So what is the product is ONA CHOH OH. Clear? Then in this the H2O get removed. Okay, I am using the H plus, so this H plus going to attach with this oxygen. So what is the product? Your product is your salicylaldehyd. Clear? Understand? Okay, so this is phenol when it react with your zinc, at the time there is a formation of zinc oxide and benzene. Then oxidation of phenol, okay, with the chromic acid, okay, produce the conjugated diketone, okay, or benzoquinone, okay, conjugated diketone or benzoquinone. The phenols are slowly oxidized, okay, dark colored mixture containing the quinone. So if it undergo the oxidation, what is the product it is going to form? It is going to form the benzoquinone. Okay, clear? Right. We will solve the question, interest question. Okay, so in this, give the structure of the product. Okay, what we will expect when it react with HCl and zinc chloride and HBr and SOCl. Okay, what is the molecule of your reactant which is given? The first one is butanol, butane 1 okay, CH3, CH2, CH2, OH. Okay, so when it react with HCl and zinc chloride, okay, then one more the reactant is your 2-methyl butane 2-ol, 2-methyl butane 2-ol. So this is your 2-methyl butane 2-ol. Okay, so 1 2 3 4, so 2-methyl butane 2-ol. Okay, so it react with HCl and HNCl2. What is going to form as your, okay, 1-chlorobutane product is going to form. If it react with HBr, what is the product? 1-bromobutane going to be formed. Okay, 1-bromobutane going to be formed. Again it react with one more reactant, that is SOCl2. Okay, so we know that, right? So in this HCl and SO2 get removed. Okay, then what is the product? Again your chlorobutane is the product. Okay, so then when it react with your 2-methyl butane 2-ol, okay, 2-methyl butane 2-ol. Okay, this is your 2-methyl butane 2-ol. When it react with again zinc chloride and HCl, what is the product it going to be? Your product going to be 2-chloro-2-methyl butane. Okay, so again when it react with HCl, what is the product? Your product is your 2-bromo-2-methyl butane. Then again when it react with SOCl2, the same product which we already got. So the 2-methyl, so 2-chloro-2-methyl butane product only we will get it. Okay, so then the second reaction is dehydration reaction. Okay, that is removal of water. Okay, the first one is your cyclohexane is there, cyclohexane. So in that 1-methyl cyclohexane, so CH3, here is the OH. If I am doing the dehydration, there is a removal of water, right? Okay, so here the OH get removed. The hydrogen either from here or from here. Okay, so if there is a formation of this one is the product. Okay, then one more product is this one. Okay, this is major product, this is minor product. I will tell you why. So if I take the hyperconjugation, here 2 hydrogen, here 2 hydrogen, here 3 hydrogen. So the hyperconjugation is 7. Okay, but in case of this one, here is 2, here is 2. So this is less stable. That is the reason. Okay, one more thing is butanol they are asking. Butanol undergo the dehydration reaction. Okay, so at the time if it undergo the dehydration reaction, there is a 2 product, hydrogen if it from the here, okay, your alpha carbon, at the time your product going to be this one. Okay, but I think they are asking the butane 1-ol, so the product is butane only. But in case if they are asking the butane 2-ol, they are asking for the butane 2-ol, okay, at the time there is a 2 hydration in the 2 different way. So one is the double bond form here, another one is double bond form here. So this is your major product, this is going to be your minor product in case of butane 2-ol if it undergo the dehydration reaction. Okay, So ortho and para-nitrophenol is more acidic, okay, compared to phenol. We know that, right? The nitro is electron withdrawing group. It will increase the acidic character. Okay, so I already discussed in great detail in previous video. Okay, so then remedium. Okay, so then we go for the methanol. So methanol we call it as a wood sprit produced by the destructive distillation of wood. Okay, then today most of the methanols are produced in the catalytic hydrogenation of carbon monoxide, okay, by using the catalyst of zinc oxide and chromic oxide. So carbon monoxide so undergo the reduction reaction in presence of your catalyst zinc oxide and chromic oxide. Okay, so methanol is a colorless liquid boiled at 333 Kelvin. It is highly poisonous in nature, I already told you. So ingestion of even small quantity of methanol can cause the blindness and large quantity cause death. Okay, the methanol is used for the solvent in the paint and varnishes and cheaply making the formaldehyde. Okay, then we go for the preparation of ethanol. So ethanol, it's obtained from commercially formation. The oldest method of sugar, the sugar molasses and the sugar cane and the fruits, okay, grapes is converted into glucose and the fructose. Okay, both of which have the formula of C6H12O6. Okay, in presence of enzyme invertase. Okay, invertase. So in presence of invertase, your sugar become a glucose and fructose. Okay, then the glucose and fructose undergo the fermentation. In presence of zymase, there is a formation of alcohol. In the wine making, the grapes are the source of the sugar. In the wine making, grapes are the source of the sugar as well as yeast. Okay, as the grapes ripen, the quantity of sugar increases and the yeast grow on the outer skin of your grapes. Okay, so where grapes are crushed, okay, the sugar and the enzyme come in contact with, okay, your sugar and enzyme come in contact when we crush the grapes. Okay, so the fermentation take place in anaerobic condition. Okay, in absence of air, the carbon dioxide is released during the fermentation. Okay, right. The next, the action of zymase is inhibited once the percentage of alcohol formed exceed of 14%. Okay, so if air get into fermentation of mixture, so oxygen of air, okay, the ethanol oxidized into ethanoic acid, which destroy the taste of the alcoholic drink. Okay, so we should not allow the oxygen inside when we do the fermentation. Okay, so ethanol is a colorless liquid. The boiling point is 351 Kelvin. It is used as a solvent in the paint industry and used in the preparation of number of carbon compounds. Okay, then commercial alcohol is made unfit for the drinking by mixing some copper sulfate, okay, and the pyridine. Okay, so this we say denaturation of alcohol. Thank you all. Okay, I will stop this video. Okay, I will resume the rest of the portion video in the next. Okay, thank you all, doing well in exam. Okay, all the best.